To begin with, this lesson was not titled properly. I have put the correct title on Composite and Inverse Functions. We're going to begin with a warm-up, and what these are, I've given you two functions, f of x and g of x, and you're going to substitute the appropriate value of x into the appropriate function, and the way you know what the appropriate value of x is the number inside the function. So this first one is f of 0, f of 2. So you'll plug the 0 into the f function. So replace that. Over here, where you have g of negative 1, you'll plug that in to this one, or substitute that in. So stop the video, and then come back in a minute to check your answers. Okay, so time to check the answers. The first one was pretty straightforward, but let's go down to this one, the third one. This time, the x for the f function and the x for the g function were both the same. We're going to substitute a 2 in where the x is, like that, and that gives us a 9. Underneath that, you've got a g of 4 minus f of 7. Now you're going to notice that I put the entire g function in parentheses to show it as a unit. And you would do the same thing here if this was not an absolute value. You do not distribute that negative inside the absolute value. Reduce the absolute value first and then subtract that 6. And then up here with the f of negative 3 and the g of 1, I substituted the negative 3 into the absolute value where x was, and I substituted 1 into the g of x where that x was, and you get a value of 20. And I have a couple of definitions for you. We're going to first talk about a composite function. Now, the examples that we did before, we were substituting something inside a function. This time, what we're going to do is combine two functions. What this says here is f composed with g. And when you have something like this, the second one listed goes inside the first one. So if we had, instead, the g came first, like so, we would say g composed with f. Now, an inverse function is somewhat like a reciprocal. And the way we know we have an inverse function, we would say g, and I'm going to change that to g of x. G of x is the inverse of f of x if f composed with g of x is equal to g composed with f of x, and they're both equal to x, and that's how we can confirm that we have an inverse function. For this slide, we're going to practice composing functions, and I have two functions. We have an f of x function and a g of x function. And what we have for our first example is we have an f of g of 3. So we're going to replace our x here with 3. Well, we're going to work from the inside out. We're going to observe the rules of PEMDAS and start from the inside out, which means I'm going to begin with substituting x is 3 into the g function. So I'm going to write down the f, because that shows we haven't done that function yet. But we're going to plug the 3 in to g of x right here. So we'll have 3 plus 5, which means we'll have f of 8. Once we have f of 8, we'll substitute the 8 into the f of x function, which is the square root of 2x. So 2 times 8, that's the square root of 16, and this is 4. And we're not going to do a plus or minus 4, we're just going to do the positive because when we are simplifying, we go for the positives. When we're solving, we will take into consideration both positives and negatives. So the next problem, we have g of f of 3. And you may think you're going to get the same answer, and sometimes you do. But let's try this one and see what happens. We're going to start with substituting 3 into the f of x, not into a g of x, which means I'm going to have the square root of 2 times 3, which is the square root of 6. And then in my g function, x plus 5, I'm going to substitute square root of 6, where the x is like that. And there we go. Okay, so the next two, I'm actually composing functions to make a new function. And we're going to put the entire g of x function of x plus 5 inside f of x. So we're going to have f of g of x and substitute in x plus 5. Now, in that square root of f of x, where that x is, we're going to replace it with x plus 5. And this is simplified. You can leave it like that, or you can distribute and go to x plus 10. Okay, so let's try the reverse. With the bottom function, we're going to substitute in the square root of 2x into my g. And so where my x is in the g function, we're going to put the square root of 2x, and then we're going to add 5 to it. And that's how we compose functions. Okay, now finding an inverse function, I'm going to show you another notation, and this looks like an f of -1 with a -1 exponent, but this isn't. You read this as f inverse. So it's not an exponent. So how to find an inverse function, how to find the function that if you compose it with the original function gives you x. The first thing you're going to do is you're going to replace f of x, or whichever function notation you're using, with y. Second thing we're going to do is we're going to switch x and y. And the last thing is we will solve for y, and that gives us f inverse. We're going to end this lesson with finding the inverse of these three functions. And the first step was to replace f of x with y. And then we're going to swap x and y's positions, like so. And then we're going to solve for y. Correct that real quick. There we go. So I'm going to solve for y, and we can do this by multiplying everything by 3. And then we will finish by adding 3 to both sides, like so. And when we're done with this, I'm going to show you how to confirm that two functions are an inverse. But let's go to the g function. The g function is still a function, and we're still going to replace g of x with y, like so. And then we're going to switch the x and the y. And then we'll solve for y. Now I'm going to add 2x to both sides and subtract x. So subtract 2y, that is. And then I'm going to solve for y. So we get 1 minus x over 2, and that's my inverse. Okay, the very last one, we have y is equal to x plus 7 over 3. We're going to switch the x and the y. Multiply both sides by 3. And then subtract 7. So we'll have y is equal to 3x minus 7. Okay, now this is the one that I'm going to compose. I am going to start with composing the inverse with the original function, which means Okay, this section equation that we got, this is f inverse, just to clarify. So I'm going to take my original function of x plus y, x plus 7, over 3, and I'm going to put that into my inverse. And so that means I have 3 times x plus 7 over 3. I'm going to subtract a 7. The 3's cancel, and you have x plus 7 minus 7, which means I just have an x, and that has confirmed, at least from one side, that this equation is indeed, these are inverse functions. And if I turned it around and did f composed with f inverse, I would still get an x because these are inverse functions.